Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry, Lesson 3-5, on polygon angle sum theorems. So we have lots of vocabulary to get through today, so let's go ahead and get started. A polygon is a closed figure with at least 3 sides that are segments. The sides interact only at their endpoints, and no adjacent sides are collinear. So here we have 3 examples of what polygons are, and we have 3 examples of what polygons are not. When you name a polygon, you can start at any of the vertices, but then you have to go in order. So this first time they start here at A, and they go around B, C, D, E. Another way to do that is they start here at D, and they go C, B, A, E. And either one is fine. You can start at any vertex you would like, and you can go in either direction. So the vertices here, of course, are A, B, C, and D. The sides are named for you, A, B, B, C, C, D, D, E, and E, A. And then the angles are also named by the letter of the vertex. Angle A, angle B, angle C, angle D, and angle E. You can classify a polygon by the number of sides. So you're pretty used to seeing 3-sided figures, those are called triangles, and 4-sided figures that are called quadrilaterals. But here are some other ones that you may or may not know already. A 5-sided figure is called a pentagon, 6-sided figure a hexagon, 7 sides is a heptagon, 8 sides is an octagon. You may have heard those ones before. These next 3 maybe not. So a 9-sided figure is called a nonagon, a 10-sided figure a decagon, and a 12-sided figure a dodecagon. And a figure that has n number of sides is called an n-gon. You can also classify polygons by convex or concave. Convex polygons have no diagonals with points outside the polygon. So a diagonal, of course, goes across from one vertice to another. And a concave polygon has at least one diagonal with points that go outside of the polygon. So for example, this diagonal here is outside of the polygon. I like to think of concave because this part right here makes a little cave inside the figure. We can also name polygons based on their sides and their angles. So if something has all 4, in this case, all sides that are congruent, that is known as equilateral. If it has all the angles congruent, it's known as equiangular. And something that is both equilateral and equiangular is known as regular. You'll see a lot of regular figures in geometry, and it is important to know that they are both equilateral, all sides equal, and equiangular, all angles equal. All right, now we're going to move on to the polygon angle sum theorem, which is our first theorem for this lesson. It says that the sum of the measures of the angles of an n-gon is the following equation. You take the number of sides minus 2 and multiply it by 180. So in your practice, they ask you for the sum of the measures of the angles of a dodecagon. So remembering that a dodecagon has 12 sides, you would do 12 minus 2 times 180, which is 10 times 180, which gives us a total of 1800. So the total number of the measures of all the angles of a 12-sided figure would be 1800 degrees. Now we move to the polygon exterior angle sum theory. Remember, exterior angles come off of a side, so here comes a side, and there's the exterior angle. So it says the sum of the measures of the exterior angles of a polygon, one at each vertex, is always 360 degrees. Since this pentagon has 5 sides, it also has 5 exterior angles. So the sum of the 5 exterior angles is 360. And to find each individual angle, you could take that 360 and divide it by 5. if this was a regular pentagon, and you would get 72 degrees for each one. If this isn't a regular pentagon, you might have to add them all up individually. All right, good luck everybody. I hope you guys all do great.